So I did mention that we're going to start basic and about the most basic we can get. And a really nice way to work with vectors is to simplify as much as possible. And we're going to start by doing that by just using one dimension and just talking about how much information we can get out of working with one dimension and where that might be useful. Okay, so we got what's essentially a number line. We'll call it the x-axis. And let's say, for example, you have a little guy that's at position 2 on this x-axis. Okay, so we could call that a one-dimensional vector, right? He's at position 2. And then let's say, for example, he's walking along, and then in the next frame, he's at position 5. Well, for a lot of calculations we want to make, like let's say, for example, we're only interested in which direction he walked. Did he walk forwards or backwards? Or let's say we want to figure out how fast he's walking. This sort of stuff. We're going to need to figure out what we call you can call the delta position. Okay, so which is really another vector. If this is a position vector of 2 and this is a position vector of 5, we've got to find out what the difference is between those two and that in that frame. So for example, how would find that out in this case? If this is vector A and this is vector B, we'd simply say that the delta, this little triangle tends to mean delta pos equals B minus A. In this case, it's just simply 5 minus 2. Which is, look, count it, 1, 2, 3. So that's equal to 3. Okay, so now we know that the change in his position, the delta meaning the change in his position, has been 3. And we're going to use that information in the future videos. So before we do the demo, I'm just going to do a little bit of quick housekeeping. I'm just going to move the web browser over here, open up the console. In case we make a mistake, it'll come up with some errors there. Let's see, I'll pop this over here. Now we want the origin to be in the top left corner just for simplicity. We'll remove this translate function. I'm going to move stroke and fill down here, maybe above the background. Okay, so we're working on let's see, the delta position. A really nice thing to do is to just write our formula in the comments so we got something to refer to. So we'll just say dx equals b minus a. And another way of writing that is we could just say dx equals, x, like our current x position, minus last x. Essentially what it's doing. Okay, so we'll go ahead and get our x position. We'll just say it'll be wherever the mouse is. We start, so we'll say const x equals p dot mouse x. Okay, we're also going to need to hold on to wherever the last x position was, and then so every frame will be getting our x position, but we want to remember where it was in the last frame. So we'll just go ahead and make a variable called last x. Let last x equals 0. Okay, and now we'll just make a new variable called delta x. Let dx equal x minus last x. And that's essentially the formula. That's pretty much it. What we're going to do now is we're going to draw it, and we're also going to have it display in text so we can read the values. Okay, first of all, I'll draw it. So we'll go ahead and do a p dot ellipse. We'll make this at the delta x, the last x position. At the last x position, the y position will be the height divided by 2, so it'll be right in the middle. P dot height divided by 2, and we'll just do 30 by 30 pixels wide and high. And let's see, we might want to make it a different color. So maybe I'll make it like a yellowish color. Let's see, 127, yeah, that'll work. And we'll do the same for the current x position. So do an ellipse at x. Maybe we'll make this like a cyan-y color. Okie dokie. The last thing I wanted to do is just display the text. So I'll just make a new variable, const text equals, let's see, I'll just write data, and this will be our x, our last x, and our delta x. So we'll go x, we'll do x dot to fixed. This just makes it, if it's a float, it'll round off all the decimal places. And we'll do last x and delta x. Okay, then we'll go ahead and display that. P.text, text at maybe just a little bit out from the top left corner, so maybe 30 and 30. Let's see how that looks. Okay, it's a little bit small. I'm going to make that a bit bigger. So we'll go p.text size, maybe 24. And also I want that color to be just the text to be black. Okay, and I can see a little mistake I made here as well. Oh wait, no, not background. Sorry, Phil. 2 mistakes. Okay. I'm drawing the ellipses and then I'm drawing the background over them. So I'm just gonna make sure that I do that background before I draw the ellipse. Draw the ellipses. Ellipsi? Ellipses. Anyway. Okay, so now we've got our position. Oh, and we can see here that this yellow one, which is rendering the last x, that's not moving because I've forgotten to update that last x at the end of every frame. So below p.text at the very end, we'll just go last x equals x. Okay, now we can see we've got our x position, and the last x is following just behind it. It's a bit difficult to see what's going on, so I'm going to go ahead and slow down the frame rate a lot. Let's say p.frame rate, maybe 3 frames per second. Okay, this should give us a chance to sort of see what's happening. Okay, we can sort of get a feel for the numbers here. We've got our delta x is going negative when we're going backwards and positive when we're going forwards. If we move around a lot, those numbers, the delta position is much bigger. Alright, and that's pretty much it for the delta position.